हेलो स्टूडेंट्स, वेलकम टू माय यूट्यूब चैनल लर्न लॉजिकली विद दीपक सर। आज एक बहुत इंपॉर्टेंट टॉपिक हम डिस्कस करने जा रहे हैं, स्टडी करने जा रहे हैं। इट इज़ वेरी वेरी इंपॉर्टेंट। लेकिन टॉपिक शुरू करने से पहले उसका कंसेप्ट हम बहुत अच्छी तरीके से पढ़ेंगे। द नेम ऑफ द टॉपिक इज सर्कल। अब देखिए, सर्कल आपको जब भी अगर 9th 10th क्लास में पढ़ना है तो उसका बेसिक सारा कंसेप्ट आपका क्लियर होना चाहिए। ओके, अदरवाइज कहीं ना कहीं दिक्कत जरूर आएगी। तो शुरुआत करते हैं फ्रॉम द बिगिनिंग। Okay, what is circle and related to circle all the information that is very very important to solve the questions. Okay, तो देखिए इसमें सर्कल में क्या क्या होगा। तो पहला अगर पॉइंट वाइज अगर हम देखते हैं, दिस इज अ सर्कल कंटेन वन सेंटर। ओके, so this one is a circle, it contains center. Okay, and this center is represented by O. Suppose any point, okay, this curvature part is called as a circumference of a circle. Any point lies on this circumference, suppose represented by A. So this distance from center to the point A is called as radius, represented by R. Okay, now suppose if we draw two radius, okay, like this, and both are form straight line. Okay, not straight line, line segment, and this line segment is represented by AB. This is called as a diameter. Okay, diameter of a circle. So length of the diameter of a circle is always twice or double of its radius. Suppose if we represent this OB by again r plus r gives diameter of circle, that is d is equal to 2r. So we can write diameter of a circle is equal to twice of radius. Okay, so this diameter is also called as the longest chord. Now what is chord? Chord means, suppose if we join any two distinct points lies on the circumference of a circle like this. If suppose this is point P and this one is point Q, suppose if we join these 2 points, it forms a chord. Okay, so chord is a line segment obtained by joining two distinct points lies on the circumference of a circle. Okay, now so this is a diameter, this is a chord. Suppose if we think about one line. Okay, one line means it is extending on both the side. Okay, never ending on both the side. That's why we represent any line by giving arrow at both the ends like this. This represents a line. Okay, now suppose this line is represented by L. Now line is represented by L, and this line is intersecting circle at two distinct points, suppose x and y. Okay, only this distance x and y is said to be the chord of a circle. This x y is said to be the one line segment. Okay, this line segment is obtained when this line L intersect this circle at two distinct points. Okay, this distance x to y represent chord, but this line L which intersecting circle in two distinct points, suppose x and y, is called as secant of a circle. Its name is secant. Okay, so this line which intersects the circle in two distinct points is called as secant. So this is the basic information about circle. Now the next information is, again we can draw one circle and we write more information about the circle. Again, this is a circle, suppose. Now think about one line, and that line is supposed touches the circle like this. This is a circle having center C or O, and one line which touches the circle at one point. Okay, this point is suppose M. Okay, so this line touches the circle. Okay, touches the circle means the point of contact. Okay, this is a point of contact of this line. Suppose this line is represented by AB. AB is a line, okay, which touches the circle at one point M, and this point is said to be the point of contact of circle and this line, and this line which touches the circle is said to be tangent. Okay, and this point M is called as point of contact. Point of contact of tangent and circle. Okay, understood? So any line touches the circle at one point, that point is called as point of contact, and that line is always called as tangent to the circle. Okay, Now suppose if we draw, if we join this center with this point of contact M, now this is nothing but the radius. OM is a radius. So there is a one property, tangent radius theorem. Okay, it is called as tangent radius theorem. So this point of contact with a joined with the center. Okay, so the line segment so formed is said to be the radius. OM is radius. Now what is the property? So radius and tangent, okay, are always perpendicular to one another. Okay, so this angle is always 90 degree. So radius means when we join center to this point of contact of tangent and circle, okay, this radius is always perpendicular to the given tangent at point of contact. Now one more thing, suppose this is a circle. So the question is, how many tangents can be drawn to the given circle? Okay, we can draw infinite number of tangents like this, like this, like this, like this for a given circle. So for one single circle, how many tangents can be drawn? Infinite tangents. Okay. One more question. Suppose how many parallel tangents can be drawn for a given single circle? एक सिंगल सर्कल में कितने पैरेलल टेंजेंट ड्रॉ कर सकते हैं? ओके, तो देखिए यहाँ दिस इज 90 डिग्री. सपोज दिस वन इज अनदर line segment which line suppose touches the circle at point N, and this is what another tangent to the given circle, and this tangent is parallel to this. Why? Because this is a diameter. Suppose this is a diameter which is a line segment MN. So number of tangents which are parallel to one another are only two tangents. Okay, so other than these two tangents, third tangent is not possible to draw for this given two tangents which is perpendicular to one another. Okay, only two tangents can be said that they are parallel to one another. Okay, for a given circle, because this one is again 90 degree, this is the diameter. Okay, and this 90 degree and 90 degree forms co-interior angle. That's why these two lines are said to be parallel, and these two lines are nothing but the tangents to the given circle. Now the next property of circle is how many tangents can be drawn for a given circle from an external point. Okay, suppose if you draw one circle like this is a circle, and this one is the center of circle represented by O. If we take one point outside the circle, that is P, okay, so how many tangents can be drawn this from this external point to the given circle? So if we draw one line segment, one line like this, okay, which touches the circle at this point M, and another line touching the circle and passing through this point P is represented by N. So Pn and Pm are said to be two tangents can be drawn from the external point to the given circle. Okay, and the important thing is that the length of these two tangents from this external point is said to be what? Equal. So distance Pm is equal to distance Pn. Okay, now suppose according to the tangent radius theorem, if we join this O with this point of contact of both the tangents like this OM and ON, we know this radius is always perpendicular to the tangent. So this is 90 degree, this is 90 degree. Again, by the by construction part, suppose if we join O to P like this. Okay, before joining, one more thing, this forms a quadrilateral. Quadrilateral is PNOM. We know angle sum property of the quadrilateral. The sum of all four angles is always 360 degree. Okay, sum of all the four angles in any type of quadrilateral is always 360 degree. Now we know measure of these two angles is 90 each. So sum of these two is means angle M plus angle N is equal to 90 plus 90, it is 180 degree. Okay, now what is the sum of remaining two? Therefore angle O plus angle P is always 180 degree, because 180 plus 180 is 360. So what is the measure of O and P in this case? But the sum is always 180 degree, because the remaining two, that is M and N, the sum of this triangle is 180 degree. That's why the remaining two means O and P. The sum of O and P, angle O and P, is again 180 degree. Now suppose if we join this O to P, okay, if we construct one line segment, we joining by joining O to P. Now this quadrilateral is converted into two triangles, this upper one and this lower one. So by congruency rule, these two triangles are said to be congruent. Why? Because these tangents are equal in length. By the property of tangent drawn from the external point, they are always equal in length. So these two tangents are equal in length, these two radii are equal, and this OP is common for both the triangles. Okay. So by triple S congruence rule, these two triangles are said to be what? Congruent to one another. That's why we can say that this angle is always equal to this one. Okay. By CPCT test. Okay. And this angle is always equal to this one, again by CPCT. Congruent part of congruent triangle. So these two triangles are congruent to one another. So this is very, very important property regarding this circle topic. Now the next one is, suppose there is a chord to the given circle. Chord means like this. This is a chord represented by A and B. AB is a chord. This is a center. This is center O. What happens if we draw a perpendicular from the center to the given chord? If we draw the perpendicular from the center to the given chord, means this angle is 90, this one is 90. Okay. So this property state that or show that when we draw a perpendicular from the center to the given chord, it always bisects the chord. With this perpendicular line segment suppose represented by OM. Okay, if it is perpendicular, then it divides the given line segment into two equal parts. So this part is equal to this one, means AM is equal to BM. Condition is OM should be perpendicular to AB. Okay. Or vice versa, if two line segments, this and this, are equal and this distance is joined, suppose if these two are equal, then this line segment OM is said to be perpendicular to AB, that is a chord. Okay. Now suppose if we join this A to O and O to B, it forms again two circles. Okay. Now these two circles are congruent to one another, either by RHS test, okay, or by triple S, because two sides are equal, 90. Okay, these two sides are equal, these two are radii, and this is common side. Now if these two triangles are congruent to one another, then these angles are also equal by CPCT. This equal to this and this equal to this. Okay, understood? So when radius is given and perpendicular distance is given, suppose this radius is given and perpendicular distance from the center to the chord is given, it is possible to find out the length of the chord. Okay, how can we find the length of the chord? If radius is given and this perpendicular distance is given, then by Pythagoras theorem we can find length AB, okay, AM, and this AB is twice of AM, because these two parts are equal. So okay, so this part is very, very important. Clear? So next one is next one is, this is a circle and O is a center of a circle. Clear? Now the next property state that suppose circle circumference, okay, circumference is divided into two parts, that is called as the arc of a circle. If we think about this curvature part, okay, this to this and this curve part, and these are the end points of this curve part, so this is said to be the arc of a circle. Okay, this is said to be the smaller arc is said to be the minor arc, and the remaining one is said to be the major arc. Okay, this topic is very, very important. AB is said to be minor arc. How to represent arc? Suppose in between AB there is another point, suppose X. So arc of a circle, which is said to be the minor arc or simple arc, it is denoted by AXP, okay, and arrow. This one, okay. So AXB is the what? Minor arc. And suppose if there is another point Y in the remaining part of the circle, so this AYB is said to be major arc. AYB is said to be the major arc. Okay, AYB. It is represented by like this. Okay. Now the next is, suppose if we joined the endpoints of a arc. Endpoints of the arcs are A and B with the center. Here, this one and this one. These are the two endpoints of arc. Okay. Now, suppose we have to find the measure of the arc AB. Measure means how much angle it forms. Okay. So, measure of the arc is always equal to this angle, and this angle is called as central angle. Okay. This angle is called as central angle. Now, how central angle is formed? It is formed either joining the endpoints of the arc with the center, or it is also formed by joining, suppose this is a chord AB, and if we take this A and B are the endpoints of the chord, again if we join O with this endpoints of the chord, again it forms the central angle. That's why the measure of this arc AB or AXB is said to be the measure of central angle. Okay, so we can write measure of arc AB or AXB is equal to central angle AOB. Clear? So this central angle is nothing but the measure of arc, or measure of an arc is equal to the central angle. Then what's about the next one, that is this, okay, this arc. Now the measure of this remaining arc is said to be the reflex of this central angle. Reflex of central angle, reflex of any given angle can be expressed as, suppose any given angle is represented by x degree. Okay, reflex of this x degree can be expressed as 360 minus x degree. This is called as the reflex of given angle x. Okay, so if this central angle is represented by AOB, okay, measure of the remaining part of the this angle is said to be what? Suppose measure of the arc AYB, we have to find, it is nothing but the reflex of angle AOB, and reflex of AOB is nothing but 360 degree minus angle AOB. In such a way, the remaining angle can be find out. Okay, understood? So this is about the arc of a circle, minor arc as well as major arc. Now the next one is, suppose if this arc AB or chord AB, okay, inscribed one angle in the remaining part of the circle. Remaining part of the circle means, suppose this is the arc AXB, and this, and if we take any point Y in remaining part of the circle, and if we join this Y with the end points of chord or arc, this is said to be the inscribed angle in the remaining part of the circle. Okay, so how many such inscribed angle can be formed? So by taking different points on this remaining part of the circle, if we take this point, this point, this point, or this point, or this point, and if we join all the points like this, okay, it forms so many inscribed angle. Okay, so first we think about one inscribed angle, that is angle AYB. So what is the measure of this AYB? It is always equal to half of the central angle, means angle AYB is half of angle AOB. Suppose if we take another point over here, and if we join this end point of the chord with this point. Okay, suppose this point is represented by Z. So this is another inscribed angle formed by endpoints of chord or R. Now what is the measure of this angle Z? So angle Z is again half of central angle AOB. In such a way, we can draw different angle, okay, infinite number of angles, okay, inscribed angle on this remaining part of the circle other than this arc, okay, this one, this one, this one. So measure of all the angles so formed is always said to be equal. Okay, so inscribed angle in the same part of the circle are of equal measure. So this is very, very important property of a circle. Now the next one is think about two equal chords. This is a circle. Think about two equal chords. This is chord AB and this one is chord BC. This is AB and this one is CD. Clear? Now if AB is equal to CD, AB is equal to CD, these two chords to the same circle are equal in length having center O. Clear? If two chords are equal, then their distances from the center is always said to be equal. Distances means, suppose if you draw a perpendicular from the center O like this, and this one is also another perpendicular for this chord AB. So this distance is suppose represented by OM, ON. If chords are equal, their distances from the center are equal. Okay, so OM is equal to ON. This is another very important property. If chords are equal, then their distances from the center are equal. Or suppose its opposite statement, if distances of two chords AB and CD from the center are equal, okay, if this is equal to this, then we can say that these two chords are equal in length. Okay, understood? One more property of the circle. Suppose if we draw one quadrilateral inside the circle, okay, and quadrilateral having four vertices like this, 1 2 3 4. Now this is a quadrilateral. So quadrilateral inside the circle, okay, represented by A, B, C, D. So this quadrilateral is said to be inscribed in a circle. Clear? Such a quadrilateral is always said to be the cyclic quadrilateral. Okay, it is cyclic quadrilateral. Now, if the center is O, the important property of this cyclic quadrilateral is the sum of opposite angle is always 180 degree. Means angle A plus angle C is 180 degree. Okay, and angle D is and angle B is again 180 degree. Clear? Any quadrilateral inscribed in a circle, then it is called as a cyclic quadrilateral. Okay, and the sum of opposite angle is 180 degree. Or other way, suppose if the sum of opposite angle, okay, is 180 degree in any quadrilateral, such a quadrilateral is always said to be cyclic. Means if this plus this is 180 and this plus this is 180 degree, such a quadrilateral is always said to be cyclic quadrilateral. Understood? Okay, this is very, very important properties of circle. Now, suppose if there is a question, suppose one circle is there. Here, how many circles can be drawn using the same center? Center O. How many circles can be drawn using the same center? Okay, we will try. This is the first circle. This one is the second circle. And this one is the third circle. Clear? So infinite number of circles can be drawn using single center. Okay, all these circles are said to be concentric circles. Okay, remember, having common center, number of circles can be drawn. All the circles are said to be concentric circle. Okay, so this is very important topic. So now in the next video we will take some questions related to this one, that is again very important regarding board examination and all. So we will discuss next question in next video. Till then, goodbye.